Hello everyone. Thank you for joining my session on containerization and orchestration of the Mautic application. I hope you will have a great time, and this is my first time in a DrupalCon, and I'm hoping that I'll be making use of your productive time. So, this is a bit about me. I work as a site reliability engineer at Excellent Technologies, and I have about over 9+ years of experience in IT. I worked as a system administrator in the beginning, and then I moved out to a better role. And currently, I'm now working as a site reliability engineer. So these are some of my hobbies, and I'm currently working on OpenShift, GitLab CI, Ansible, and Kubernetes. And I basically love contributing to the Kubernetes project. So I'm actually making my efforts uh, for giving my best for the Kubernetes community in the coming days. And I'm also AWS community builder. So there's a program in AWS which is AWS Community Builders program, which is uh, where like-minded professionals who are enthusiastic in contributing to AWS come together and contribute to the community. So I've recently been absorbed into that program, and I'm very glad that I'll be working in the next coming days. And as just as how the Drupal community is, even the AWS community also is growing bigger and bigger. And I hold two certifications, one in AWS Solution Architect, and another one is a Certified Kubernetes Administrator. And these are my social media handles. If you would like to connect with me, please do contact me, and we will get in touch. So these are some of the key takeaways from my session. I would be explaining a bit about architectural design of the application, how we have decoupled different components and made use of native Kubernetes services to address the problems, and how we manage Docker image updates, and then how we consolidated all the configuration files available inside Mautic and brought them into one single file called config.php, and some security considerations. And most of the part of our session would align with 12 factor app methodology. And I'm hoping that you guys are aware of 12 factor app methodology. If not, then you would be knowing in the coming time. So, what is Mautic? Well, Mautic is an open source marketing platform. It has been very famous in the recent times, and it has been the greatest advantage of using Mautic is that it provides the greatest level of integration and deep audience intelligence. And you could also do email marketing, social media marketing, marketing analysis, lead generation, and ROI reporting. Many of the digital marketing strategies or digital marketing campaigns can easily be run using Mautic. So coming to the customer's problem statement. So when one of our customer has come to us that they were running Mautic on a AWS infrastructure on a normal EC2 virtual machines, and they wanted us to help them because they some of the challenges they faced was that the scalability of their applications during their intense marketing campaigns, and also how they were having a tough timing of managing the application updates. So these were major concerns of the customer when they came to us with this, and that's when we started working on this particular Mautic application. So on initial analysis of the Mautic application at that point of time, when we checked, what we saw is that Mautic application is a totally not enterprise ready and not in line with the 12 factor app methodology. Well, there are multiple configuration files that have been to inject environmental variables, and that was one of the tough factor where there are many multiple files involved in this, and managing all those files together was very hard. And apart from that, there was also an open source Docker image for Mautic, which was not enterprise ready, leave alone running it on Kubernetes or any of the container orchestration engines. So apart from that, there is also the ephemeral and persistent components like the logs and cache, which are not decoupled. So, and including all this, there's another factor also where there are multiple processes running in the same container. So that is actually an anti-pattern to the containerization. So taking all these facts into the consideration, we have designed our architecture like this. So the architecture has the following components. It's the Kubernetes, and we have Mautic and Nginx deployed as a service where Nginx ingress controller has been used as the load balancer. And then we use cron jobs to run intense marketing campaigns. So previously, whenever the marketing campaigns were run, the customer had to have a lot of load on the application. So we decoupled that, and we made use of Kubernetes cron jobs to run the scheduled or ad hoc marketing campaigns. And we also used RabbitMQ as a separate service, and so that it reduces the load out of the application. And we also have MySQL instance running as an RDS in AWS. This has not much of change because the earlier use also was on AWS RDS itself. So there is not much change on the database side. It was running on RDS before and even after we worked on it. And then we also have an application load balancer, which acts as a front end to the Nginx load balancer or Nginx ingress controller. And we also have Route 53, which is a DNS service from AWS that we have used for all the DNS related queries. So if you look at the diagram, or if you look at the architecture, we also made use of the EFS volumes, which are the kind of block storage or file storage for in the AWS. And for cache, we actually disintegrated and we made the logs and cache upload to a PVC. I mean, which is again a volume that is being used by the which is a EFS volume. And so how did we start the work? So the first thing that we started to work was decoupling of different components from the application. So what we did was we actually decoupled the application container from the web tier, thus ensuring that all the app and the web have their own resource limits. So previously what happened was that they were using both application and the web tier in the same server. So thereby the traffic to the server is very high and it's causing a lot of problems. So as part of the 12 factor methodology, we decoupled both the web tier and the app tier, and so that each of them has their own resource limits and they could actually work independently. And for, as I said before, we also use cron jobs, which run in parallel to the application. And whenever there is a need for a batch job or a scheduled or a ad hoc marketing campaigns. And then we also decoupled the messaging queue and we ran it as a distinct service on the platform. And apart from that, the next thing that we were trying to do is that the configuration file. The There were many configuration files to talk about for Mautic, and all we did was we wanted to consolidate all of them, and we brought all of them into one file called config.php. So this particular config.php is the file which has the database information and other connection information. So that whenever there is a change or whenever there is uh, a change needed, it would actually be only updated in the config.php. Next is the Docker image updates. So the reason why we separated this out is that in order to make the application extensible, what it did is we, like for example, whenever a developer adds some plugins or extensions, So they actually have to build the whole source code from the beginning in order to have the changes reflected on the website. However, in this case, what we did was that we added the composer install command as part of the Docker image, Docker file, so that all the developer has to do is that just add the extensions and plugins that they want in the application and let Docker take care of installing all of them. So this is one of the important part because it saves a lot of time and it actually saves the time of the developer. It actually builds new image whenever there are changes. And apart from these, we also went on to do further improvements where the most important aspect in the containerized world is also security. So what we do is that since security is paramount when containerizing the applications, what we did is that we made sure that all these containers are running as a non-root user so that we reduce the attack surface on these containers and uh, make sure they're tightly secured. So when we come to the deployment section, we have used these tools, GitLab CI/CD, Terraform, and Amazon EKS. The reason why we chose GitLab CI/CD is that because of its declarative way to create a CI/CD pipeline. And along with that, it also has an easy integration with the Amazon EKS, which is Elastic Kubernetes Service from the Amazon. So the declarative configuration of the pipeline makes it easily configurable and customizable. So the build, when it comes to the build process, what happens is that whenever there is a building of images involved for Mautic and the Mautic Nginx, and what happens is that once these images are built, they are pushed to the ECR registry. ECR is nothing but Elastic Container Registry, which is a container registry software from the AWS. So in the deploy step, that is a build step. After the build is done, the deploy step, what it does is it pulls the image from the ECR repository and deploys them onto the Kubernetes. So by doing that, what happens is that every time a code is checked into the non-master branch, a new namespace is created in the Kubernetes with the branch name and application is deployed uh, into the particular namespace. Thereby, you don't actually have to create multiple Kubernetes clusters. You can just create multiple namespaces in a single cluster and manage all your applications. This is the advantage that we have with EKS, or for the matter of fact, with the Kubernetes. And apart from that, the reason why we have chosen GitLab over other CI/CD tools is that it only has a YAML-based CI file, which is GitLab-ci.yaml. So what happens is that whenever we define something inside this YAML file, these definitions could be reused, and only changes to the uh, all you have to do is that you just have to change the variable names. So that's one of the reasons why we have used GitLab CI/CD for our CI/CD. And then coming to Terraform, since uh, in the previous instances, what happened was that the customer was using it on EC2 instances. They deployed the Mautic application on EC2 instances. But here in this case, what happens is that Terraform was used to create a EKS cluster along with the persistent volumes for EFS and RDS. So what happens by this is that all the infrastructure is set up within few minutes, and that is the reason why we used Terraform. And within few minutes, we have an EKS cluster up and running, and then we can proceed with the application deployment. So Terraform in that way helped us a lot, and we personally recommend Terraform over any other infrastructure provisioning tool. And for once Terraform deploys the infrastructure on on the AWS cloud, that's when we use Helm charts for the Mautic application. So we also developed a Helm chart in-house for deploying the Mautic application, which has the actual application configuration. So this particular Helm chart has been made in such a way that it is completely parameterized and portable. So whenever uh, you want to deploy an application, or for the matter of fact, whenever you want to deploy a Mautic application, you just have to go and change the values.yaml file. So this values.yaml file is something like a configurable file which actually has the values of all the variables. So once you deploy once you change the values in the values.yaml, you can go ahead and deploy the uh, Helm chart. So that's what we used for deploying a Mautic application on our EKS cluster. And then uh, the reason uh, the reason why we use AWS EKS is that because there are many reasons why we chose EKS, but some of the reasons that we chose over others are we have when it comes to the costing, as you know, hosting involves costing, and every customer wants to save money on hosting. So when it comes to EKS, what happens is that $0.10 per hour is charged for the cluster's master node. So, I mean, if you ask me, it's very cheap and it's like affordable for running huge workloads, or if you're running something on a temporary basis. And as I said before, you can actually use only a single EKS cluster and deploy applications in the form of in different by using different namespaces, or you can even deploy multiple EKS clusters. So that is one of the way where we actually took advantage of the AWS environment. Apart from that, and also we also have EKS. Along with EKS, we also have AWS Fargate and also on-premise, which is called AWS Outposts, which has been a very good solution in the recent times from AWS. And another cost effective solution is that if you are using EC2, so we have master and worker nodes in the Kubernetes cluster. So if you're using EC2, you only pay for what you use. So which is very cost effective because you're not being charged for on the whole of a server, but just the utilization of whatever you're using. And another important factor for any modern cloud native application is that autoscaling. Autoscaling is very important, and in this particular case, it is very much needed because the customer was having heavy workloads running, and they wanted to make sure that the application is stable and working fine even if the workload is high. So autoscaling comes in handy whenever such a requirement comes, and it takes a load during the uh, peak marketing campaigns. So these are some of the reasons why we chose Amazon AWS EKS solution for hosting the Kubernetes workloads. So I think I'm hoping that the session was helpful, and I think we can now start with the Q&A session.